Okay, so Friday we were talking about logarithmic functions. We talked about how a logarithm is just the inverse of what? The exponential, because all it does is flip the x and y. And we were focused on graphing then. With these, we can also solve equations. So that's our piece from today. If I give you this equation, and I ask you to find x, any ideas on where you might start? That's a very good idea. Put it into exponential. So remember, the base of the log is the same as the base of the exponential. You go across the equal sign, so it'd be 3 squared equals 4x minus 7. We can solve that. 3 squared is 9. Add our 7 and divide by 4. One thing that we do have to make sure we do on these is check our answers. Both the base and the argument must be greater than 0. So the base of the log has to be a positive number. This thing in the parentheses has to be positive. So just a quick check, when I put in 4 times 4 minus 7, is that a positive number? Yes, so we're okay. If it gave us a negative, then we would just say no solution. And we kind of saw that when we graphed our logs. The standard log had a domain from 0 to infinity. We could only have positive numbers there, so that's where that comes into play. So let's try the second one. Log base x of 64 equals 2. So how do we write that? How do you get rid of a square? If you add a square root, you have to do? So I get x to be positive or negative 8. Are both of those acceptable? Because I said the base and the argument both have to be positives. The only thing that could be negative is what it's equal to here. So x has to be a positive number. So positive 8 is the only answer here. All right. I'm going to put up a few for you guys to try. So, okay, what does a negative exponent do? Okay, so this is like saying 1 over x squared. What could you do now? Okay, so a couple options. There's a property that says if you wanted to flip this side, you just have to flip this one. Maybe a little more obvious. If you cross multiply, you get 16x squared equals 9. So x squared has to be 9 over 16. What would you do now? Square root, plus and minus. So we get positive and negative 3/4, but remember, the base has to be a positive number. So 3/4 is my only option. get 16 to the 3/4 power equals x. What's a 3/4 power? What does that mean? Fourth root of 16 cubed. I know you could just put it in your calculator, but I like thinking through it. What's the 4th root of 16? 2. And what's 2 to the 3rd?
8.
Is positive 8 an okay answer? Yeah. Alright, let's try some more. I don't know why my log looks like that, but log base 36 of the square root of 6 equals x. We change that to exponential. 36 to the x equals the square root of 6. How am I going to solve this? You could square each side, and that would work. Or you could change it, the square root, to a fraction and get a common base. So both options will work. We'll have to get a common base eventually, so I'm just going to start with that. 36 is 6 to the 2nd. Square root of 6, that's 6 to the 1/2. Isn't these, this is like those exponential equations we were solving last week. So 6 to the 2x equals 6 to the 1/2. So that means if the base is the same, the exponents have to be equal. Divide by 2, and we get 1/4. Okay, quick check, 1/4 is fine. The x, what that it's equal to, can equal anything, so we didn't have to worry about it anyway here. So, if we're solving these equations with logs, we can change them to exponential and use all of our same strategies from last week. Get a common base if necessary, and solve from there. Questions so far? The next thing we need to talk about is some properties of logs. So I'm going to put these up here. I'm going to let you guys write them down, and then I'll talk about them. So I do have some stipulations up here because the base and the arguments have to be positive. That's why I said x, y, and a are all positive numbers. R can be anything here. Okay. So this is telling us how we can break apart logarithms. And it has to do with properties of exponentials. So if you think about exponential, if I said like 3 squared times 3 to the 4th, when you're multiplying, what do you do with those exponents? You add them, right? So when I have the log of things being multiplied together, I can split them up and add the individual logs. If I gave you 3 to the 5th divided by 3 squared, what would you do with those exponents? Subtract them. So properties of logs. If you have the log of two things being divided, you can split them up and subtract the individual logs. The power property. So if you have an exponent, you're allowed to bring that down in front as a coefficient. These last two things here, they're kind of properties, they're kind of things that we could just think about. If you think about what a log means, we talked about Friday how it's asking for an exponent. If I said, for instance, log base 5 of 1, that means 5 to what power equals 1? 0, because anything to the 0 power is 1. If I said log base 5 of 5, that's saying 5 to what power equals 5? That's the first power. So that's where these come in. not necessarily that you have to memorize them as properties. We just know when we're evaluating logs, that's what's going to happen. So let's practice using these properties a bit. If I asked you to evaluate this without a calculator, you have to be a little careful on those calculators anyway, because when you push the log button, it's log base 10. So if you're trying to do log of 2, there is a way to put them in. I'm not going to lie and tell you you can't do them on there, because you'll figure it out. You can, but it's very difficult to get to. And I will require you to show me work on these, because I want you to do it without a calculator. So it's preparing us for solving equations where we have variables. So we need to know how to do this. If I could try to think through this, but it's not real obvious. 8 to what power equals 2? 8 to what power equals 4? You know, you might be able to think through those, but it's a little more challenging. However, if I have a log base 8 and a log base 8, when those logs are added, what could I do with these arguments? Multiply. So if I did that, 2 times 4 equals 8. So that's saying 8 to what power equals 8? 1. Okay. And this one. Log base 6 of 18 minus log base 6 of 3. If you have the log of two things being subtracted, how do you put them together? Divide. You just have to do 18 divided by 3. Make sure the one that had the minus is what goes on the bottom. So that's log base 6 of 6, which is 1. So these properties can make it much easier to solve things in some instances. A couple other results. I told you that the exponential and the log were inverses of one another. We know that inverses just cancel each other out, right? If you have a cube root and a cube, they cancel each other and just give you what was under the radical. So if you have both an exponential and a log, when the base is the same, they really cancel each other out. So these two properties, if I have a to the log base a, those would drop and just give me the n. If I have log base a of a dr, those log base a and a's drop and just give me dr. So you might want to jot those two things down as well. They can help us simplify some problems. So if I asked you to solve this. X equals 3 to the log base 3 of 8 power. We could try to work this out, but the shortcut, if we recognize it, the base of my exponential and the base of the log are the same. That means they're inverses. Those things really cancel each other, so x is just 8 from that property we wrote down. B. X equals log base 4 of the cube root of 16. This one, there are a couple different ways to do. Give me one option. What comes to your mind? Yeah. If you don't see anything else, we can always change it to exponential. 4 to the x equals the cube root of 16. Right, this is an exponential equation, which means we have to be able to get a common base. So what could I do? 2? Okay. So 4 is 2 squared. 16 is 2 to the 4th. So I get 2 to the 2x equals, how would I write the cube root of 2 to the 4th? 2 to the 4/3. So then you can set your exponents equal, divide by 2, and x is 8/3. Okay. Not the only way of doing this one, but it works. Questions there? And we're going to do just a couple more, maybe one more slide of examples, and then I'm going to stop for today. So I want to practice using these logs to expand, and this is where we will pick up tomorrow using this. So we will talk about expanding and condensing. When I expand, I'm breaking it apart into multiple logarithms. So if I say log base 7 of 8 times 6, if I want to expand, when you have things multiplied, what do you do with the logs? So we have to write log base 7 of 8 plus log base 7 of 6. You have to put the log base 7 on both of them. You can't leave off the base. If I see a log without a base, it's assumed to be 10, so that is something different. So make sure you're writing that both times. The 7 is a subscript, so it should be a small number there. Right. B. What do I need to do here? Subtract. So we would put log base 6 at the top minus log base 6 of the bottom. All right, C. First of all, the 4th root of r cubed, how could I write that? The 3/4 power. So then the 3/4 comes down, log base a of r. And D. All of this is under a square root, so let's deal with that first. What do you want to do? Well, how about, we don't want it to just go away, but a square root is like what power? Square root is the same as a 1/2 power. What would you have to do with that exponent? Yeah, we have to multiply each of those, so it becomes r to the 3/2. S, 2 times 1/2 is just 1, over t, 4 times 1/2 is just 2. How many different logs am I going to end up with here? 3. Each of these variables has to get its own. So we have the log base a of r to the 3/2. R was multiplied with s, so plus log base a of s, divided by the t, so we need to subtract. If you have multiple things on the bottom, Like if I had an X down here, I would also subtract that one off. So anything on the bottom gets subtracted. But I'm not done yet. What's wrong with it? Exponents can come down. So you can either rewrite it, or if you just want to bring those down right here, so it would be a 3/2 log base A of R plus log base A of S. This one, 2 comes down, so minus 2 log base A of T. So tomorrow, we're going to work a little more with these properties. We're also going to do some review. I'd like to do a quiz on Wednesday over sections 1, 2, and 3. So section 1 was like our inverse stuff. Section 2 is all the exponential equations, and section 3 is the log equations. So that's the plan for the next couple days. So your homework right now, 14